That moment when your DIY stove fails, it's more than just disappointment. It's a lesson in physics you just failed. But what if you could build a stove that works every single time? One that's efficient, safe, and almost indestructible. You can, you just need to follow 5 simple rules. Welcome to the blueprint for the Unbreakable DIY stove. We're not just avoiding mistakes, we're engineering a tool. Forget the hacks that barely work. Let's build something legendary. Alright, let's dive into the first and most critical principle, the airflow equation. To master fire, you must first understand its most fundamental need. We all know the fire triangle: heat, fuel, and oxygen. But what most DIY stove builders get wrong is the oxygen part. They treat it as an ingredient to be passively added, when in reality, fire is a living, breathing entity. So, rule number 1, and burn this into your memory. Fire breathes air, it doesn't eat it. Think about it. You don't just hold air in your mouth and hope for the best. You inhale, process it, and exhale. Fire works the same way. It needs a constant directed flow, a respiratory system. Without this, you're not building a stove. You're just building a smoky can of disappointment. The most common and fatal mistake is giving your fire air only from the top. Look at this, holes punched around the top rim, with the fuel sitting at the bottom. The builder thought, fire is hot, heat rises, so the air should go in where the flame is. It seems logical, but it's fundamentally backward. This design is actively suffocating the fire before it even has a chance to establish itself. What happens is the rising heat and exhaust gases from the weak flame create a barrier, pushing away the very oxygen trying to get in. The smoke, which is just unburnt fuel, has nowhere to go but to choke the combustion process. It's a traffic jam of physics. This is precisely why so many homemade stoves fail, producing more smoke than heat and leaving you with a cold dinner and frustration. Trying to feed a fire this way is like trying to breathe through your ears. It's a nonsensical approach that ignores the basic mechanics of fluid dynamics. You can't force air through an exit path. You need a dedicated intake and a dedicated exhaust, and they cannot be in the same place. This is where the genius of ancient engineering comes into play, a principle that will transform your stove from a failure into a furnace. The Unbreakable Stove doesn't fight physics, it harnesses it. It uses a powerful, timeless principle, the chimney effect, also known as the stack effect. The concept is beautifully simple. Hot air is less dense than cold air, so it naturally rises. By creating a vertical channel, a chimney, you create a pressure difference. The rising column of hot exhaust gas actively pulls fresh, cold, oxygen-rich air in from below to replace it. Here's how we apply it. Cold air is drawn in from large intake vents at the absolute bottom of the stove. This is the mouth. This air travels inward and feeds the base of the fire, right where the fuel is gasifying. As the fuel combusts, the superheated, expanding gases and smoke have only one place to go: up and out through the exhaust vents at the top. This upward rush creates a vacuum at the base, which in turn creates a powerful, self-feeding, and continuous draft. The fire is now breathing on its own. The faster the hot air exits, the more cold, oxygenated air is sucked in. This virtuous cycle intensifies the combustion, creating a miniature vortex of fire. It's no longer a passive flame, it's an active, roaring engine. The result is undeniable. More air in the base means a hotter, cleaner burn. The flame turns from a sooty, inefficient yellow to a clean, intensely hot blue. A blue flame is the sign of complete combustion. You're not wasting fuel by turning it into smoke. You're converting nearly all of its potential energy into pure, usable heat. This means you use less fuel, boil water faster, and leave virtually no trace. Ultimately, it's the difference between a campfire and a forge. A campfire is pleasant, but it's inefficient and smoky. A forge, which uses a bellows to force air into the base of the coals, can reach temperatures hot enough to shape steel. By mastering the airflow equation, you are elevating your simple can stove from a mere campfire into a high-performance forge, capable of incredible thermal output. This is the foundation upon which everything else is built. We've arrived at our second and arguably most critical rule, the material mandate. This isn't just about what works, it's about what's safe. The materials you choose for your stove can be the difference between a hot meal and a trip to the emergency room. It's a decision that demands your full attention, because the wrong choice can have severe, lasting consequences. Let's start with a fundamental truth. Rule 2. Your life is not a soda can. It might seem tempting, they're everywhere, they're lightweight, they're easy to cut, but that convenience is a trap. So, let's be unequivocally clear. Do not use aluminum soda cans for a stove. The melting point of aluminum is around 1,220 degrees Fahrenheit. A well-designed wood-burning stove can easily exceed that temperature. They will melt, not might, will. Imagine your pot of boiling water suddenly collapsing into the fire because its support structure has turned to liquid. It's a catastrophic failure waiting to happen, creating a mess at best, and a serious fire or burn hazard at worst. Now let's talk about an even more insidious danger. It looks tough, it looks durable, but it hides a toxic secret. And never ever use galvanized steel. You'll find this zinc-coated steel in things like buckets, ductwork, and some types of fencing wire. It's designed to resist rust, not high heat. When heated to temperatures above 900 degrees Fahrenheit, well within the range of a camp stove, the zinc coating vaporizes. It releases zinc oxide fumes. This isn't just a bad smell, it's a poison you are actively breathing in. That's metal fume fever, a debilitating flu-like illness with symptoms like fever, chills, nausea, and muscle pain. In severe cases, or for people with pre-existing respiratory conditions, it can cause permanent lung damage, and it can put you in the hospital. It's a miserable, completely avoidable experience. So what should you use? The answer is simple and reliable. The Unbreakable Stove is made from plain, uncoated steel. Think of large food cans, like for tomatoes or coffee or stainless steel. These materials have much higher melting points and don't have toxic coatings. It's the boring, safe choice that won't kill you. There are no surprises, no hidden dangers. It's robust, it's predictable, and it's chemically stable at the temperatures you'll be operating at. This isn't the place for exotic materials or clever recycling hacks that compromise your health. Your stove has one primary job, and it's not to be a science experiment. Your stove should cook food, not poison it. Always prioritize safety over convenience or aesthetics. Choose your material wisely, and you'll have a reliable companion for years to come. Rule 3. If it wobbles, it will fall. Spilling a pot of boiling water on yourself is a life-changing event in the wrong way. The Unbreakable Stove has a low, wide base of support, and it has a way to secure your pot. This isn't just about convenience, it's about preventing third-degree burns when you're miles from help. A stable stove is a safe stove. Rule 4. The ground is not your friend. You might be focused on the flame, but the real danger can be underneath. The Unbreakable Stove always has a heat shield. A rock, a metal plate, something that interrupts the heat transfer to the ground. Because the goal is to cook your dinner, not the entire forest. Rule 5. Know your fuel and respect your flame. The wrong fuel can turn your stove into a bomb. The Unbreakable Stove is designed for a specific fuel, whether it's alcohol, twigs, or solid fuel tablets. Each fuel type has its own unique properties, its own personality. Alcohol burns clean and quiet, but it's nearly invisible in daylight, a silent hazard if you're not careful. It vaporizes easily, and those fumes are highly flammable. Wood is beautifully primal, connecting you to the oldest form of fire, but it demands constant attention, a steady hand to feed the flames. Solid fuel tablets are compact and reliable, but they can leave a sticky residue and have a distinct odor. Understanding these nuances isn't just trivia, it's the core of safe and effective operation. Your stove is a system, and the fuel is half of that system. Using the wrong component is like putting diesel in a gasoline engine. It won't just fail, it will fail catastrophically, and you never ever add fuel to a hot stove. This is the single most dangerous mistake you can make. It's a moment of impatience that can lead to severe burns or an uncontrolled wildfire. When a stove is hot, especially an alcohol stove, It's not just the liquid fuel that's present. The air around it is filled with invisible, flammable vapor. Pouring more fuel into this environment is like throwing a match into a room filled with gas. The flame won't just flare up, it will leap up the stream of fuel you're pouring, turning the fuel bottle in your hand into an incendiary device. That's not a cooking fire. That's a Molotov cocktail you're holding in your hands. There is no safe way to do it. There is no shortcut. The laws of physics are absolute and unforgiving. The risk is never, ever worth the few minutes you might save. This pact with your flame is non-negotiable. You respect its heat, and it will cook your meal. You disrespect it, and it will burn you. Measure your fuel before you light. This simple act of preparation is your first line of defense. By measuring the exact amount of fuel needed for your cook time, you eliminate the temptation to refuel mid-burn. It forces you to be deliberate. You learn how much fuel it takes to boil a liter of water, how much to simmer a meal for 20 minutes. This knowledge turns guesswork into precision. It also prevents you from overfilling the stove, which can lead to dangerous spills of liquid fire when you light it. A few moments with a measuring cup prevents a lifetime of scars. And let the stove cool completely before refilling. Completely, not just until the flame is out. Not just warm to the touch. Cold. Metal retains heat far longer than you think. Even without a visible flame, the residual heat in the stove's body can be well above the flash point of your fuel. The only way to be certain is to wait. Give it 10-15 minutes. Let the wind cool it. You should be able to comfortably place your bare hand flat on any part of the stove without discomfort. Only then is it safe. This patience is the final clause in your fuel and flame pact. It's the discipline that separates a seasoned woodsman from a liability. Respect the heat, respect the fuel, and your stove will be your most trusted ally. So, the Unbreakable Stove isn't about one magic trick. It's a system. It's a can that breathes correctly, made from safe materials, built on a stable base, protected by a heat shield, and fed the right fuel. Follow these 5 rules, and you won't be making a DIY stove. You'll be forging a tool you can bet your life on.